table, and we are supposed to design a circuit with input W and output according to the state table. And he gives 3 different possibilities for state assignments. So it's just the same problem done 3 different ways, but you'd end up with 3 different circuits. They all do exactly the same thing, but one of them might be lower cost than another, which would be why you would do this in the first place, why you would try out different state assignments. Okay, so first we're going to rewrite our state table using our assignments, and I'm going to also just label them. I have for A and B, it's 2 bits. I'll call them Q1 and Q2. And then we have our next state. And if W equals 0, then I'll have Q1 star, Q2 star, and if W equals 1, I'll have Q1 star and Q2 star. And my output Z, this is a Mealy machine because I have different outputs depending on my different inputs. If it was more, I would just have 1 column here and not 2 columns. And so for the first one, for part A, I just replace all my A's with 0, 0, B with 0, 1, C with 1, 0, and D with 1, 1. That's all I do. So C is 1, 0, D is 1, 1, A is 0, 0, B is 0, 1, and then the outputs stay the same. Okay, so then to draw my circuit, I need to come up with expressions for Q1 star and Q2 star. Since I have 2 bits in my state, that means my circuit will have 2 flip-flops. And we normally use D flip-flops because those are the most straightforward. Yes? I'm sure I messed up. I don't know. Thank you. So this is supposed to be 0 and this is supposed to be 0. Yes. Okay, so I'm going to start with a Carnot map for Q1 star. And I'll have Q1, Q2 on the top, and I'll have W on the side. So it'll be 0, 0, 0, 1, 1, 1, 1, 0, and 1, 0. Now, we're just looking at Q1 star. So that means we're just looking at the first bit in each of these 2 columns here. That is yellow on my computer and comes up gray on the projector here. But hopefully y'all can still read that. So this first column here, that's when W equals 0. That corresponds to the bottom row of my Carnot map. The top 2 numbers on my Carnot map are Q1 and Q2. So when Q1, Q2 is 0, 0, and W is 0, then Q1 star is 0. When Q1, Q2 is 0, 1, and W is 0, it's 0. And when Q1, Q2 is 1, 1, or 1, 0, 1, 1, 1 or 1, 0, and W is 0, then I have 1. So now I go to when W is 1. When W is 1, Q1 star is 1 when Q1 is 0, so that's here and here, and it's 0 when Q1 is 1. So then I'll make this circle, and that tells me that Q1 star equals, in this first circle, W is 1, so that's W, and what these two have in common is that Q1 is 0, so Q1 bar, or with this circle down here, W is 0, and what these two have in common is Q1 is 1. Now, you might notice that WQ1 bar or W bar Q1, that is exclusive OR. So when we go to make our circuit, we can simplify it by just using an exclusive OR, W exclusive OR Q1. Now we'll do Q2 star. And I'll have Q1, Q2, and W, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And now I'm looking at the second column, and I can see that when W is 0, that's our bottom row right here. So this part of my chart right here was when W was 0. Q2 star is 0 when Q1 is 0, and it's 1 when Q1 is 1. So it has the same pattern as this one up here. You have to be a little careful though, because our Carnot map doesn't go in the same order as we write them out here, or as we did for this first one for part A, because the way we assigned our states for part A are 0, 0, 0, 1, 1, 0, 1, 1, but our Carnot map goes 0, 0, 0, 1, 1, 1, 1, 0. So they're not in the same order. So it'd be tempting to just say this should be 0, 1, 0, 1, but it's not, because these last two are in a different order. Anyway, when W is 1, the second column here is Q2 star. When Q1, Q2 is 0, 0, Q2 star is 0. When Q1, Q2 is 0, 1, Q2 star is 1. When Q1, Q2 is 1, 0, Q2 star is 0, 1, 0, that one's all the way over here on the right. And when Q1, Q2 is 1, 1, Q2 1 star, Q2 star is 1. So that's these. So Q2 star equals, this top circle has W equal to 1, and what it has in common is Q2 is 1. And in the bottom circle, W is 0, and Q1 is 1. And I don't think I have any simplification of that. And then lastly, I need to get my output. So this is Z. And I can see that when W Why did I do 1, 0 instead of 0, 1? Did anybody want to tell me that that was weird?
Yeah, I was gonna ask if that's what you normally do.
No, it's not. It's just weird. There's nothing wrong with it. It's just weird. But yeah, it works. So yeah. I guess I'm tired from doing all this digital logic and getting ready for circuits. Okay, so we can see when W is 0 that Z is always 0. So I can just fill in 0 here. And when W is 1 and Q1, Q2 is 0, 0, that's 1. When Q1, Q2 is 0, 1, that's 0. When Q1, Q2 is 1, 1, that's 0. And when Q1, Q2 is 1, 0, that's 1. So this is our group right here. So Z equals W is 1 and Q2 is 0, so that's W Q2 bar. Okay, so now we need to draw our circuit. So because we had 2 bits for defining our states were 2 bits, we'll have 2 flip-flops. So I'll call them D1, D2. This will be Q1, Q2. We have 1 input, that's W. Q1 star is W exclusive OR Q1. So I'll have an exclusive OR gate, and it's W exclusive OR Q1. I do have a clock. Q2 star is W and Q2. And then I also have a W bar Q1. Those are ANDed together. So not of W ANDed with a Q1. So this is Q1 here. I'm sorry, these are so messy. And then these are ORed together. And that's Q2 star. Z is W and Q2 bar. So I sometimes put in often we don't draw it in, but the bottom one is the complement, and that'll just make things not quite as messy. So Z is W and Q2 bar. So I'll get my W and Q2 bar, and that's my Z. Okay, so then the next part of the question said, well, what if we had different states? What if our states were instead, if we had A was 0, 0, B was 0, 1, C was 1, 1, and D was 1, 0. So you do the state table again. And this time, everywhere where we had an A, we put a 0, 0. Everywhere we had a B, we put a 0, 1. But where we had a D, we'll put 1, 0. And where we had a C, we'll put 1, 1. So this time our table looks like this. and our outputs are the same. I'm not going to do all of it. I'm just going to do a little bit of it. So Q1 star ends up actually being the same, but Q2 star is different. So we'll do that one. Zero, one. So I'll do it in the right order this time. Now, this is handy because our states are in the same order as going across on our Carnot map. So we can just copy straight from our state table onto our Carnot map. So for W equals 0, we just go down the column there, go across here. So it's Q2 right here, and those are all 0, so I can put in 0. And for W equals 1, that's right here, that's 1, 0, 0, 1. So that would be my group, and that would get me Q2 star equals W is 1, and Q2 is 0. I think that's different. Is that different? No, no. Oh, that's what Z was before. And then if you find Z, you'll find Z is actually much more complicated. Z ends up being Q1, Q2, W plus Q1 bar, Q2 bar, W. So anyway, you just get different expressions. The behavior of the circuit will be the same. It's just how you define the states. So that's how it's different. So I am going to take about a 10-minute break before the circuits review. So if you're staying for circuits, feel free. The sign-up sheet is there.